All right, well, chapter 6 starts out with rational exponent notation and radical notation. And so we're going to learn how to go between exponent notation and radical notation. So in the first section up here, they want us to take these numbers that are written in radical notation and write them in exponent notation. So we know they're in radical notation because there's a radical symbol in all of them. All right, you see that radical, that means it's in radical notation. And we're just going to change the form of it so that we are putting it into exponent notation. So a certain value raised to an exponent. So it'll look a lot like the ones in 7 through 12 down here, because the ones in 7 through 12 are in exponent notation, and we're going to work to put those back into radical notation. So it's just two different forms of the same value. I actually want to start on number 2 because I think it's a little bit easier to see this one than number 1. When you're taking a radical and you are going to put it into exponent notation, so notation just means the form. They want the form in exponents instead. You're going to take what's under the radical, okay, that number 6, and you're going to get the exponent that we're going to raise the 6 to by taking the number outside here. So this whole cubed root of 6 is being raised to the second power here. That's going to be the numerator of my exponent. The denominator of my exponent is going to be this cubed right here. So the cubed root of 6 can also be expressed as 6 to the 2/3 power. We can use that 6 to the 2/3 power. We can actually type that into the calculator and get an answer that we can round to the nearest hundredth. All right, in number 3, we'd follow the same steps. We know it's in radical notation because it has the radical symbol in it. The 14 is the radicand, that's what's under the radical symbol. So we're going to rewrite that. That's going to become our base. And then we're going to look out here and see what exponent the entire radical is being raised to. In this case, it's a 4. And then we're going to make that our numerator. And then we're going to make the denominator the whatever is inside that root symbol inside the radicand, which in this case is fifths. So this did in radical notation, it says the 5th root of 14 raised to the 4th power. In exponent notation, it says 14 raised to the 4/5 power. It's going to give us the same value in the end. It's just that we can take the exponent notation and plug it into the calculator and get an actual decimal point answer out. All right. If you notice, I'm writing the exponents instead of writing like 4/14 and 4/5. Instead of writing it like this with the numerator directly above the denominator, I'm kind of writing them side by side with a slanted line as the fraction bar. And the reason for that is just to be a little bit clearer. You can make it a little smaller when you write it like this with a kind of a horizontal slash. If you write it this way, it can easily be mistaken as the fraction 14, 4 and 4/5. So it's just a little bit clearer to write it this way. So try to practice not writing it this way so we don't end up with confusion on your part when you're doing your homework and then on my part when I'm checking your work. So going back then to number 1, the thing that's a little bit different about number 1 is the entire radical is not raised to a power. So when it's not raised to a power, like in this one, it's the whole radical, the cubed root of 6 is raised to the 2nd power. Over in 3, the 5th root of 14 is raised to the 4th power. Here we just have the cubed root of 7. And so when it's not written specifically what the exponent is out here, we just assume it to be 1. So the cubed root of 7 is the same thing as the cubed root of 7 raised to the 1st power. We just don't write the 1 in. But we need it when we change the whole thing to to exponent notation. We're going to take the radicand, the number under the radical symbol, and write that. That becomes our base. We're going to take the 1, the exponent that the whole thing is being raised to, and we're going to put it over the 3 from the cubed root. Now in 7 through 9, we're going the other direction. We have the value written in exponent notation. we want to write it in radical notation. So we're going to write it with a radical. So I'm sure you can guess that the first step is to take the base and put it under a radical symbol. So in this case, then, we're going to look at the numerator and denominator. The numerator is 1. So this looks very similar to our number 1 up here. This entire thing is being raised to the first power. The 3 is going to sit inside the radical because we really want the cubed root of 17. The whole thing would be raised to the first power. So that's how we get that 1/3 exponent. But you don't need to write it that way. To simplify it, you can just write the cubed root of 17. So now it looks exactly like number 1 looked when we first started out with it. On number 8, we have the same deal. We've got a 1 in the numerator. It's the 1/6 exponent. So we're going to take our base of 44, put it under the radical symbol, and take that denominator of 6 and stick it right there in the radical symbol. We could write it parentheses, raise it to the first power, but that would be unnecessary and a little less simplified than just leaving it the way it is. And then in number 9, take the base again, stick it under a radical. Now here the denominator tells us we're talking about a cubed root again, and then the 2 tells us this whole radical is going to be raised to the second power. So again, they mean exactly the same thing. It's just a different form. When we want to stick one of these into the calculator, though, we're going to have to know how to take it from radical notation and put it in exponent notation, because it's the only way that we can put it into our calculator to get a decimal answer. And we'll practice that a little bit later. On 13, 14, and 16, we need to evaluate the expression without using a calculator. So we just need to follow PEMDAS. So PEMDAS, and really we only need the P and the E. We need the parentheses and the exponent. So when we are going to take care of what's inside the parentheses first, so we have here the cubed root of 8. So we're talking about a number that when you multiply it together 3 times, you get 8. So that is 2. 2 times 2 is 4, times another 2 is 8. That 2 is being raised now to the second power. And so now we're going to take care of the exponents. So 2 squared is 4. So we just did that radical without using a calculator. When you've got a perfect, like in number 8, you have a perfect cube under the radical. So that works out really nicely. Here we have a 4th root, and this is a perfect 4th root. Number 16 is the 4th root of 16 is 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So we say 2. That's what we took care of in the parentheses, and that whole thing is going to be raised to the 3rd power. So then we take care of the exponent, and we end up with 8. On 16, it's in exponent notation. I'm going to write it in radical notation, because in radical notation I can do it without a calculator. If I had a calculator, if I was going to use a calculator on this, I wouldn't do this. But we have the square root of 36. I know it's the square root because my denominator is 2. So I could write the 2 in here in the radical, but I don't need to do that, because when no number is written in there, we know it to mean the square root. Okay, so this is the square root of 36, or the second root of 36, and that whole thing is going to be raised to the 3rd power. So I can do this in my head easily, because 36 is a perfect square. 6 is the square root, raise it to the 3rd power, and I end up with 6 times 6 times 6, which is 216. Moving to the back of the worksheet, we're going to start using the calculator. They ask us to evaluate the expression using a calculator and then round the result to 2 decimal places when appropriate. So on 23, we have the 6th root of 112 raised to the 1st power. All right, the 1 is not written in there. It could look like that. It's not written in there, so we assume it to be 1. In order to put this in the calculator, we have to turn it into exponent notation instead of this radical notation. There's not any way to put in the 6th root on your calculator. So we're going to change it to exponent notation. We'll rewrite that base of 112. The numerator becomes that 1, the 1 exponent that was assumed, and then this denominator becomes the 6th root. Now, when we put it into the calculator, you have to be really careful the way you enter it in. And so there's only one way that's going to give you the correct answer. So make sure you jot this down on your worksheet so that you can go back and reference these steps until you have it down. You're going to want to plug in 112. And then you're going to find that caret key that we've used before. And here's the part that's a little bit different. We need to put the exponent in parentheses. So we're going to say parentheses, and 1/6 is really 1 divided by 6. And then end parentheses. That's going to make sure that that exponent gets calculated correctly and doesn't get mixed in with the 112. So, and then hit enter or equals, whatever it is on your calculator, and it should give you 2.19551, etc. They asked us to round to 2 decimal places, so that means we want to round here to 2.20. If you left it as 2.2, I would be fine with that as well. I'm leaving that 0 on there, even though it's not significant, just because they specifically stated to 2 decimal places in the directions. All right, on 24, I'm going to rewrite that in exponent notation. So the base is going to be negative 215. The power that this radical was raised to is 1. All right, they didn't write it in, but it's there. So that becomes our numerator of our exponent, and then our denominator is the 7 from that 7th root. So plugging this into the calculator, follow those steps again. The negative sign, 215, caret, and then your parentheses to protect the 1 divided by 7 exponent. All right, you do that, and you hit enter, and you should get negative 2.153. So that means that we're rounding to 2 decimal places, the 100th place. So when we do that, we're going to keep that 5 the same. And so our final answer will be negative 2.15. All right, and then number 25, it's already in exponent notation, so we don't have to do any changing of form. We can plug it into the calculator. 241, caret, parentheses, 1 divided by 5. And then we will get 2.995, which is going to make us round everything up. And so to 2 decimal places, it would be 3.00. Again, the 00 isn't really significant, but I'm writing that down because of the directions, the way they asked it to be written in the directions. Now, number 32, they actually ask us to solve for x. And so we've got that equation there. We're going to follow the same steps we've always followed with solving for x on problems like this. Just because it's an x cubed doesn't change anything. So I'm going to get that x cubed by itself first. And that'll give me 115 on this side. So now I have x cubed and I have 115 on the other side. So if I take the cubed root of both sides of this, so that would look like this. I'm just going to rewrite it so you can see it. That would be the cubed root of x cubed, and then the cubed root of 115. So just like when we take the square root of x squared, when we did that, let me just write that over here. So we'd have the square root of x squared, the radical and the square canceled each other out. The same thing is going to happen here because we have a cubed root now and we have a 3 exponent. They'll cancel each other out. They undo each other. And so we end up with x equals the cubed root of 115. So now, as long as we remember how to turn that radical notation into exponent notation, we can plug this into the calculator. So in order to do that, I'm going to rewrite the base, 115. This whole radical notation is being raised to the first power, All right, it's not written in, but it's raised to the first power. That becomes my numerator in my exponent, and then the cube from the cubed root becomes my denominator. So then when I plug this into the calculator again, be 115 caret parentheses 1 divided by 3 end parentheses and equals, we get 4.8629, etc. We're raising it to the hundredths place again, so we can see that that's just going to leave us with 4.86 as our final answer.